Hello, I'm Li Hao. So today we're going to do a Christmas special. Over here in my screen, you see a Christmas tree from Advent of Code 2020. Once you finish Advent of Code, you will see a Christmas tree. And we are going to do that. We're going to replicate this Christmas tree. But instead on the browser, I'm going to do it on a terminal. It looks like this. And yes, if you see this carefully, it's animating. And if I resize my terminal, it's responsive. Okay, so we're gonna do a responsive Christmas tree. So what we're gonna do is we're gonna print this tree without using any dependencies. We're gonna figure out how we can print a Christmas tree, how to print a color, and how to do an animation, and how to do a responsive Christmas tree with colors on terminal. Okay, so we're gonna do this right now. Ho ho ho! So let's get started by creating our script and open it in VS Code. Let's have the Christmas tree side by side with our editor. And let's inspect this Christmas tree and figure out a pattern out of it. Right, so imagine this is a rectangle, the width and the height of the Christmas tree. So luckily we have levels of this Advent of Code over here, right? So the height of the tree depends on the number of levels. So height, in this case, we have 24 to 1, right? We have 24 levels. The height of the tree is 24. And the width, let's see. So we can see of the width of the tree, it starts with 3. And this is 5, right? Let me zoom this a bit. Right, you see that the tree is 3 and then 5 and 7. So every layers, we add 2 more on the side. Right? So the tree starts with 3 and then 5 and then 7, right? 3, 5, 7. So it will be every layers we have 2. So the width will be something like 2 times the height plus 3, right? We can imagine every layers, every levels you have extra 2, right? So it starts with 3, 5, and then all the way to the height times 2. Plus 3, right? 3 is the initial width. And if we ignore any padding, right? Probably we add 2 padding. We add paddings on both sides, right? So it'll be plus 2 for the padding. So here I'm gonna say padding equals to 1, and padding times 2 for both sides. So this is the width of the tree. Right, so to print this out, so we're gonna print a shape of the tree first, and then figure out like how to print the leaves and the bells and different colors and stuff, right? So to print a tree, we need to print the spaces and then the tree and then the space, right? So we print and then we print line by line. So this will be a for loop, for let. So we will start with the first line. So line equals to let's see. Let's first 0 to line less than the height, line plus plus. Okay. And along the line, we are going to know. We need to keep track of what's the width of the tree. Right. So the width of the tree, I'm going to call it width of tree. It starts with 3, and then for every line we're going to increment by width of 3 by 2. Okay, and we need to also keep track the space. Okay, let's see, I think this is getting a bit unwieldy. How about let's do this, right? So technically you can have commas and declare a lot of variables here, right? I was thinking of declaring like the space over here equals to something, like let's just say like something, and I'm gonna, so space every line, so this is 1, this is 2, this is 3, right? So every line is actually decrement by 1. I was thinking doing this, but I feel like this is getting, because I'm zooming into the code and there's like we're adding declaring a lot of variables, this gets a bit messy. So I'm gonna declare the variable up top here instead. So line is 0, width let's width of the tree is 3. Let's space. Okay, I haven't figured out the space, but I'm gonna do that later, right? For loop, so we don't have the initial condition. And then for every line of for loop, after every iteration, we're gonna increment +2. We can also do this over here so that it's so we can have it each of them at its own line, right? So this we don't have initializer. Each initializer, we don't have things to do because on each iteration, at the end of each iteration, we add it here. So this is kind of similar to a while loop, right? So we can replace this with a while loop because this is just a condition, okay? So while the line equals less than the height, right? This is, we're gonna print from line 0 all the way to line height 24, right? Less than, okay? So we need to figure out a space. The space starts with, so here is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we have 1 to 24, then the height, the space would be 0 to 23, right? So the space is actually the height minus 1 and decrement all the way to, yeah, just decrement, right? We don't really care what's the end of it. We just make sure that we print out 24 lines of tree. Okay, so we get all the parameters, the space, the width of the tree, and then the line. Wait, number of lines, right? So let's print that out. So console log. So we're gonna print a space first, right? So this console log, every line of console log, it's printing one line, right? When you say console log, you print something per line, right? So this is what we're gonna print for that line. So for that line, we are going to have a padding, right? So every line we have padding. So that would be a space. Repeat by padding. Right? So padding can be any size. Like this is a variable we can control. So but if it's just 1, then repeat 1 time. We have a padding, and then later on we also need to end with a padding on the right side. And here we need the space, right? This will be a space again. Dot repeat space plus, and we need this as well on the right side. And I'm gonna print the tree. So the tree will be a star for now. Repeat the width of tree plus. Okay, let's save this. Let's try a run. Let's note Merry Christmas. This is our tree, like our primitive tree. Okay. In the meantime, we need to print out the trunk of the tree as well. So the trunk at the end, this is, let's see how many characters. 1, 2, 3, 4, 5. Right, 5. So there's 3 spaces and then like the pipe character in between. A pipe, 3 spaces and a pipe. So the width of trunk equals to 5. Right, so the whole width, this is the width of the entire sort of like the canvas we have all the way here, right? So we need to figure out how much space we need on both sides of the trunk, right? That would be the whole tree, right? The width of the tree, width of the tree. Width of the tree. No, actually it will be this, right? It will be this. Width of the tree, probably at the end of the loop we still have extra 2. Yeah, because we will reach the end of the tree and then we still increment line, which is line 25, and the width of tree will be the extra 2 more, right? So you can have the width of the tree minus 2, width of 3 minus 2, which should equivalent to 2 times the height plus 3, right? These 2 should be the same, okay? But let's just use this instead. So this is the width of the tree. We are going to minus off the width of the trunk, right? Which is 5, and divide by 2, which will be the space for trunk equals to this. Okay, once we have this, hopefully it's a even number. hopefully the width of the tree minus 2 minus of this width of the trunk would be a even number. But if it's not, let's floor this so that it makes sense to repeat in integer. Right? So we're gonna print out the trunk console log. So we're gonna have a space time repeats the space for trunk, and then plus the trunk itself. So with the pipe character, 3 spaces. Okay, 1, 2, 3. A pipe character plus space, space repeat space for trunk. Oops. Okay, and I'm gonna do this 2 times, and let's see. And then we're gonna draw a floor, right? Let's just draw all underscore all the way, right? So this will be this, this, and here we're gonna have this. Okay, let's save this. Let's try run this. Oops, this is too much space. Okay, wait, let me think. Why does this happen? Okay, so the width of the tree, okay, I think because of this whole thing divides by 2 rather than width of the trunk divided by 2. Okay, let's try draw that again. Yes, we have our tree. The shape of our tree is here. We need the star. Right, let's come up here and try to print that out. So 1, 2, 3, 4, 5 characters apart, which means the space. So the star takes 1 less space. 2, 3. Okay, right. So this will mean white space, right? White space dot repeat. This will repeat extra 2 more spaces than we have from here, right? This plus 2 plus plus this. Okay, let's do this. Okay, let's draw out the star. It goes to this. We have space, pipe, space, this, space, okay, this, pipe. Whoa, okay, this is. I think we don't need this. We only need to escape this character. And then lastly, we have the others. Let's see. It should be a dash. Dash star dash. Okay, this is our star. It probably looks like this, but we need to escape this forward slash. Okay, we have our star. So this takes up one less space, right, than our tree, because this is 5 characters apart, but initially our tree is 3 characters. So we need to console. Okay, let's for loop for star line of star, console log this dot repeat. Okay, how about this? Space for star equals to space minus 1. Okay, repeat space for star plus the star line plus this dot repeat space for star. Okay. Yep, I think that's it. Let's try it out. Okay, I think how come we are not centered? 1, 2. Space for star. So actual exact space. 1, 2. Let's see, why is this? Okay, we don't, because we forgot about padding, right? This is correct, but we need padding to make it right? So this dot repeat a padding plus this repeat padding. Okay, let's save this. Right, this is correct. So if we have padding with say 5, then this is okay. This trunk needs padding as well. Let's do that. Repeat padding plus repeat padding. Okay, so actually we can, yeah, it's okay. I was going to say we can draw the trunk with this shape as well, right? This shape over here. But we have written this, so let's leave it as it is, I guess. Let's have our plus. Okay, let's try this. Yay, we have our Christmas tree printed black and white with a padding that can be changed, and you can change the height as well. So this is height of 24. We can make it like 10, and this is a smaller tree, or we can make it 20, right? Slightly bigger tree. So any size you want, it works. Now it's time for colors. We need to color our Christmas tree. Okay, so this is the beginning of the challenge. Right, so in terminal, so this is what I just learned for this video. Okay, I may be saying something wrong, but correct me or comment in the section if you have a better resource, or if you know this better than us. Just share your this is a season of sharing, so share your knowledge. Okay, so we have if we want color in the terminal, we need an Ansi code. And Ansi stands for, I need my notes. Ansi stands for American National Standards Institute. So it's a standard, Ansi, ANSI, Ansi. I'm not sure the pronunciation of this abbreviation, but this Ansi standards dictates like what are the characters or control sequences there is for your terminal. Okay, so there's this thing called the Ansi escape code, which is a sequence of escape characters that allows you to control the terminal. Right, you've seen some like very cool terminal programs that you can basically choose options, have some sort of animation, have colors in your terminal, and things like that. These are controlled through Ansi escape characters. Okay, and these characters are so I read this, right? Platform support. These are widely supported in Unix-like system, and for Windows, Windows console does not support, but since 2016 in Windows 10 there is support, but it's not turned on by default. Okay, apparently this is added because there's a Windows subsystem for Linux. Because all Linux, like all Unix or Unix-like system, which is like Linux is one of them, supports this Ansi escape codes, right? So this was added in, but unfortunately this defaults to off, right? So you need PowerShell 5.1 to enable it. And in 2019, which is 2 years ago, this is supported by default in the Windows terminal, which is intended to replace the Windows consoles. So if you're using Windows terminal, this should work. Okay, and other operating systems, terminal systems, I'm not familiar with them, so I'm gonna go through them. Okay, so these are sequences that once you print them out in a console, they will do something. A few familiar control characters or special characters we know of are like line feed, which is like printing a next line, and yeah, okay, I don't know anything else. So how are we going to print them out? So these are hexadecimal code. So it starts from 0 to 16 characters, right? So it's 0 to 9 and then A to F. And we need to print hexadecimal code to do this, right? So and this, from what I discover, is part of the ASCII character, ASCII table. If you open the ASCII table, you see that the first 127 characters in the ASCII is also part of the Unicode table. And so let me open Unicode table as well, Unicode character table. So this, so they are actually Unicode characters, right? And the first 127 of them is part of the ASCII table as well. So I think from here beyond, it's slightly different, right? So since after 7F, here are slightly different characters than you have in, because they are no longer ASCII and they are extended ASCII, which looks a bit different, right? So I'm opening this too because here you can see the decimal, hexadecimal, and octal character of the code. Okay, and we need to print out the hexadecimal code to do this, right? So if you look at here, bell is 7 in a hexadecimal, right? Which is here. It's the same thing. 7 in a hexadecimal. Since it's 7, it's the same for decimal, hexadecimal, and octal. And it's here as well. The 7th character is called a bell. So if you look here, it says that it makes an audible noise. So you want to try do this. So if I come over here, run my node, and I print console log, I need to print a hexadecimal character, right? So if I print 7, it's just 7, but I need to print a hexadecimal 7 character. So how do I do that? If I look at string in JavaScript, you see that there's a special escape sequence. Over here, it allows you to print a Unicode code point between 0 to FF, right? And which these bells, like this first 255, right? 255. Wait, I think more than. Okay, my math's failing me, but this number of, I think this is 255, right? 256 characters. Yeah, 0 to 255. 256 characters of this. If you want to print them out, you can use this escape sequence to print this code point out, or else it just treats as normal string characters. Okay, so we want to print. So when we print 7, it's actually where's 7 in this character set? 7 is the code point is actually 55 in decimal, which is hexadecimal is 37, right? So if you want to print 7, it's actually console log. The escape sequence is /x and 37. This prints 7, right? This is the code point 37 in hexadecimal for 7, right? 7 is this. Right, so when we do normal like printing, like console log, it's just printing this character, and it's actually represented in hexadecimal is actually 37, right? So if you want to print something less than, something else, like say for example, like characters in here, you need this special way to actually print them out, right? So what we want is print a hexadecimal code point of 7 rather than the character 7 itself, right? This will ring a bell. Let's enter. Oh wait, hold on. Okay, so we need 2 characters. Okay, so if 7, it's actually 07. Do you hear that? Okay, I'm not sure whether you can hear my recording, but it's actually beeping. Let me. Yeah. So this is, hopefully it's not too loud. Okay. So now we want to escape. Okay. Why do we need to escape? Because if you scroll down here, with this control sequence introducer, scroll down all the way, you start to see you can color, set background color and stuff. Okay. So this select graphic rendition, you need to do a CSI and then some code. Okay. So CSI 0 and then and then it ends with M. Okay, so CSI 0M, it's like reset all the attributes. But CSI with like 20, like 30, and then an M is like sets a foreground color of like 30, right? So what is 30? We're going to look at that later on, but I'm going to do this. Okay, so CSI, how do you do a CSI? You scroll up again. CSI is escape with a open bracket. Okay, so escape, if you scroll up again, is this, okay, which is a code point of 1B. Okay, if you see over here, 1B, where's 1B? 1B, escape. Okay, this is the code point 1B, which is escape. Okay, we're gonna print this escape 1B, and then we're gonna print a open bracket. Open bracket, where's the CSI? Escape and an open bracket, and then this is a CSI, control sequence introducer, and then with that, we're in this control sequence, we introduce a control sequence, and then we're gonna specify our attributes, things that we want to do, and then we end with M, right? So things we're gonna do is here. And you can see that it says that several attributes can be set in the same sequence, separated by a semicolon. Okay, so we're gonna do a few things, and then we separate by semicolons, and we end with M. Okay, sounds confusing. Let's take a look at how we're gonna do. Okay, so here we're gonna print out 1B. So this is the escape character, and then we follow with an open bracket. So this is the control sequence introducer. We're gonna introduce control sequence now, and then we are going to set color. Okay, so set foreground color is 30 to 37. If you scroll down here, there's actual code point that you need, like code that you need, right? So we're gonna set, this is foreground, this is background. So we're gonna set a background of 101, and maybe the character foreground will be the text itself, background will be the background of the text, right? So foreground will be, maybe let's choose white, 97, right? So separated by semicolon and 97, and we do a M. And then now we've done all the control sequence. Now let's print some word, right? So I'm gonna say Merry Christmas. And if I end here, I will, because this controls the current terminal, right? So it will have effect on the whole terminal until we reset it, right? So we're not gonna reset first. Let's take a look at how the effect. Okay. So now we press enter. You see it changed the terminal to red background with white text, and now we see our Merry Christmas. And now if we keep doing whatever, you see that the text is still, the whole terminal is in red background, white text. And we're gonna change this. We need to reset this back, and reset is 0. Okay, so it's CSI and then with M. So we're gonna do that. Console log. So the escape first, and then the open bracket. Right, so this is the CSI, and then we have M. Let's print this. Yes, we reset it back. Okay, so now we realize how we can do this. Now let's come back to our code and figure out how we're gonna print some colors in it. Okay, so if you're using a library called Chalk, this will do it for you, and how it does is using Ansi characters. So today we're not going to use any dependency, we're gonna do it raw. Okay, so we don't need this anymore. We're gonna play around with all this special graphic rendition parameters to change our terminal. Okay, so first let's take a look at the colors. So let's come back to here. We need green. Okay, green color for the tree. So now we need to print this with green, right? So here we're gonna have the green color CSI, and then we need to reset it back, right? The reset. So reset, let's have that. Okay, reset is /x 1b, the escape. This is the CSI with an open bracket and then with an M. Okay, so we're gonna print this instead. Okay, now we need to set color green. Okay, which is /x 1b, open bracket, and for color green. Okay, this foreground color green is 32. So we're gonna do a 32M. And let's save this. Let's try to, okay, let's exit this. Wait, exit. Okay. Let's do this. Note Merry Christmas. Now we have our tree in green. Okay, we need a, is there a dark green, bright green, green? Yeah, this is green. Okay, this is my green in my terminal color. You may see a different color in your terminal because I style my terminal a bit, so the color is slightly different from what you're gonna see in your terminal. Okay, so we are going to print the actual tree, that exactly the one we see in this place. So we need a few colors, right? We need green, we need blue, orange, red, and yellow, and they are actually different things, right? So let's have them over here. So the tree, I'm gonna call it leaf or bell. Okay, we have a few options. So the first one is a yellow star, right? A yellow star. So this plus reset, and we're gonna start with /x 1b open bracket. Let's see what's the color for yellow. Yellow would be 33, foreground color 33 M. Okay, this is the star, and let's have the O. I think this is an O. Okay, you can actually do use, have this everything together if you like, right? If this is what you fancy, you can do this as well. 1b open, and if you find that repeating this, you don't like doing this, you can make it a variable as well, like the CSI equals to this. Yeah, it's up to your fancy. Okay, so since we're doing this, we do this. Now we have the reset. Okay, and the color that we are going to for is blue. So what is blue? Blue is 34. Okay, and we need a few more. Let's take a look over here. We need alias with red. Okay, I say red, and a small O with orange, and then a leaf with green. Okay, and then a leaf with green. So we have this or this in green. Okay, so let's find our color. Green is 32, so this is 32M. And this is 32M. Orange is orange. Where's our orange? Oh no, we don't have orange over here. Okay, we don't have orange over here, then we probably need 8-bit colors or even more colors, right? So let's choose a color. I think this is nice, 208. So for 8-bit colors, you need a different sequence, right? Escape, open, and then this, right? So it will be 38, semicolon, 5, semicolon, and then M. This is foreground color, right? And 208, right? This is what we want, 208, and semicolon, and then M. Okay, this is for orange. And then we need red. So red, I think this is 31, is good. 31. Okay, now we have everything. Leaf or bell. Okay, so we're gonna print, we're gonna randomize printing all this over here instead. Okay, so rather than printing just the asterisk, I'm gonna remove this. I'm gonna randomly print something over here. So this is gonna be random leaf width of tree plus. Okay, so this is gonna be a function. Function random leaf of tree, the width. So let string goes to this return string. I'm gonna form a string. So for let I equals 0, I less than width, I plus plus, string plus equals to, let's see, I'm gonna random this So this with math.random times this dot length, and we're gonna floor this whole thing. Okay. Okay, I think it's done. Okay. So we randomly choose one and then we put it, choose it from the list of bell, and then we add it to the string and then we return this. Okay. Let's try and run this. Note, Merry Christmas. Oh, resets. Because we define this later on. So we push all the way up, resets. Let's run this. Whoa, okay. Okay, I think we print extra 1 characters here, right? 0 to width 1, 2, 3. It's correct. Why are we having too many? 1, 2, 3, 4. Repeat random leaf. Let's see what went wrong over here. What's the width? Width is 3. Wait, sorry, console log width and then string dot length. Wait, should be correct, right? Wait, string dot length leaf or bell. Wait. How should I do this? Because too many control characters, that's why. This is correct. Okay, so leaf of bell, something is wrong over here. Let's take a look at here. Comma, do we miss some comma? Probably something is wrong with this. Yes, this is supposed to be O. Okay, we don't need this, right? Yeah, I think when we copy paste, we add an extra alias in. Okay, so here, let's print this. Merry Christmas. Okay, we have our tree now. It looks a bit weird because the side can be anything, but it looks more normal over here because the size is always, on the left side, always the less than sign, and the right side is always the less than sign, and the left is always the greater sign. Okay, so that is a special, so I'm gonna say left leaf equals to this, right? I'll put this here, and the right leaf is always equals to this. I'm gonna put this here, and we need our left and right leaf here. Left leaf plus right leaf. Okay, so this now we can minus by 2. So the width of tree is always just like 1, 3, 5, right? So we start with 1. But every line we also plus 2. Okay, so this is, we just change the initial width, and then we print a left leaf, right leaf over here. Right? So let's save this. Let's run. Right? This looks better, much better. Yeah, much better. Except that I feel like we have too many bells over here. Right? So this is. How about this? We don't do bells. We separate this, and we have a different probability of hitting a bell or a leaf. Right, so here is the leaves, is the left and right leaves, and this is the bells, which are this, and here we are going to have our first probability first, random. If it's less than a 0.8, so we have 0.8 probability of getting a leaf, so a string plus equals to the leaf. Alright, leaves, right, and else we have our probability of getting a bell. Okay, so if you notice here, this repeats. If you don't fancy this, you can have like a random choice function that takes in an array and then randomly choose one for you. So here it will be something like this, return. This will be replaced by the array. So random choice of leaves or random choice of a bell. Right? So this is the probability of getting a leaf, right? Less than 0.8 is always leaf, and more than that is bells. Let's save this. Let's try run again. Yes, but it's too little bells now. Let's get like 25% of getting a bell, right? This is kind of more like it. Not really. I think this is too little. Let's just like tip this less. Okay, now it looks better. Okay. Now, of course, the star needs to be yellow, right? So yellow color is, I think we did this before. This is 33. So let's come here. Let's have our 33 for the star. Right. So console log the CSI plus 33M. Right, this is the yellow color, and then now we need to print out the reset. Okay, so let's take a look. We have our yellow. Okay, printing our reset itself will create a new line. So let's console log without a new line. Right, I can't remember what was that. Console log without new line. Can't remember what's the parameter again. Okay. Okay. So console log is always a new line. Okay. So I think we need. Let's just do this. Right. Process standard. Process dot standard. Whoa. Process standard out dot write reset. Okay. So we don't console log a new line. Or alternatively, you could also do this on every line. Right, just set color yellow on every line and reset it on every line. Right, so let's clean this up. Okay, so this is our star and our tree. Okay, so now the last thing is we need to do some animation. Okay, so animation is we're gonna print this. Okay, we're gonna clear the whole terminal, print a Christmas tree, and then wait for a few seconds, sometime, maybe 1 second. We clear the terminal again and then print a new tree. Okay, so while doing that, when we print a new tree, because we do a random of the bells, right? So every time the tree will look slightly different, right? So we have an animation like that. So to do that, this whole thing is the printing of the tree, right? So we're gonna add a while loop here. Big while loop to wrap the whole printing of the tree. If you fancy, you can make it into a function so that makes more sense. Yeah, I think we just let's do that. Let's just mix it into a function. So function print tree. Okay, so we're gonna call the print tree in a fixed interval. Okay, so to do that, there's a few ways. You can set timeout or set interval to do that. Keep setting an interval, right? Or you can use a promise. You can use a timeout. So you print something with a timeout and then print again, right? So you fancy any way you like. So you can do like set interval, print tree. Actually, before printing a tree, I'm gonna do something first, right? So here I'm gonna just do this. We're gonna print a tree every 1 second, right? If you see this, you have a print a tree every 1 second ish. Except it looks a bit ugly. I'm not sure why okay. I think I need my initialize variable over here in the print tree function as well. So it's always printing. Let's say space for star. Right. Print tree. Okay. I think we need to print a tree first before and then we start a new interval, right? So there's a lot of different ways to do this, right? One, I said like interval, wait, while loop, timeout, and stuff like that. I'm just gonna show you another alternative. It will be while loop true, and then print a tree, right? And then you wait for like a timeout. Right, and now like timeout, like So you print a tree, wait for it, and then print a tree, wait for it. So at least you don't see print tree 2 times, right? To do a timeout, to do this, you need a top level await, or you can make it, you can push the whole thing into a immediately invoke a sync function here. So you can do this. So at least you can use await over here. But for the timeout, you can import this function called the promisify from util, equals util, right? So promisify will transform a callback function to promise. So this is a package from Node.js, so you don't need to install any dependency. Okay, so here you can promisify the set timeout. Let's change a set timeout into a promise version. So let's do that instead. Let's remove this. Let's try this. Right, print a tree, wait for a second, print a tree, wait for a second, print a tree. Okay, now it doesn't look that great because we haven't cleared the screen. Right, to clear the screen, what you need again is some Ansi control code. Okay, so what we need is clear erase in display, right? Clears part of the screen, and clear number of lines. So if you don't specify number of lines, it will clear from the cursor to the end of the line. Or wait, erase in display, right? If you don't specify, it will clear to the end of the screen from where your cursor is. So what we're going to do is we're going to do this CSI with cursor position. We set back to like the top left corner. So we move the cursor to row N and M, 1 base, so default to 1 if omitted. So we can CSI with a H which move, or CSI 1 semicolon 1 H. Right? So let's write that in the meantime. Right, so here we're gonna console log CSI plus 1 semicolon 1 and then capital H. Right, CSI 11H, or you could omit this according to it, right? And we do a erase display, right? So we're gonna do this, and then we do a CSI again plus erase in display. N is missing to the end of screen, so end of screen. So we leave this empty and we press J, right? You pass in J. So this will clear the screen, and this will print a tree. Let's run this. Clear screen, print tree. So you see that it always clear the screen, print a tree, clear the screen, print a tree. So you see this bell transforming in real time. And now we need, but if you try to scroll this, it still looks ugly, but just please don't scroll this. Because I haven't figured out how to lock the scrolling. But if you see this, it's not that recursive, responsive. Are you able to do some responsive in this? Let's try this. The height is fixed. The width is based on the height. So if we can come over here when we do a print tree, we figure the width, we figure the height, right? If the height is, every time we print a tree, the height is based on the terminal heights, then it will be amazing. So let's try and see whether we can do this. So this you can get the value of the height of the terminal from the standard output columns, and of course we need to take into account of how many lines the stars have and how many lines the trunk takes up, right? We need to minus that 2 off. Right, the trunk is 3 lines, the star is 3 lines. For now, we're gonna say 6. Okay, but I think if you like it to be nice, you can stars.length plus trunk.length and make this part of the stuff. So I'm gonna do this, and so my height is a bit of responsive. So every time when I print a tree, I get a new height, right? So probably when I resize, it changed a bit, but then later on when I the size of the tree does not change, but the next time it prints, it will resize the tree, right? So let's see how it works. Okay, the number of columns is not that correct, right? So something wrong with number of columns, right? So let's try console log, and return here first. Process standard out dot columns. Okay. Okay, it's not number of columns, it's number of rows. Okay, my bad, rows. Okay, so let's try this. Okay, we have this tree, and we try to resize. Next time it prints a smaller tree. If I scale, you have a bigger tree, right? Semi-responsive Christmas tree. If you want a very responsive, just print it as fast as possible. I think that would be amazing. Or you can listen to maybe some standard out event, standard out on. I'm not sure you have a resize event, right? And then with this, you can print another tree quickly, right? So gonna just print tree. So let's try this and see. Resize, immediately it prints another tree. And of course, you have your set interval to continue printing a tree. Resize. Wow, that's faster than I thought, but it's quite nice. Responsive Christmas tree in your terminal. I think this star is missing out a bit because of this cursor is pushing it out, right? So I think we should let's see, how should I do this? I think it's because of the last new line that we have, right? I think so instead of console log, either we print process, so make this disappear, or maybe quick way is just -1, right? The height is always height of the console -1, so we just take this into consideration. If you want nicer, figure it out. This is your job for Christmas. Okay, I'm not doing it for you, right? So let's do this. Merry Christmas. You see the full star, and it's responsive, and there you go. Merry Christmas. An animated Christmas tree in your console. We learned Ansi code. We learned how to do a for loop, print a Christmas tree, and that's it. Hope you have a good Christmas. So if you like this a lot, spam the like button, share it on Twitter, share it with your friend. If you have or you have a different version of the Christmas tree, show it, print screen it, and share it. I think this is a season of sharing. So if you like this, again, share this video, comments and like. It will do me much favor, because this will tell YouTube that this is an amazing video you should recommend to everyone, right? So till next time, see you, bye bye, Merry Christmas.